Applications of trigonometry in real life. This is a very important concept connecting trigonometry because most of the real life problems are solved using trigonometry, and hence applications of trigonometry is an exclusive chapter which we are going to discuss in the session. So to start with, let's start with the line of sight. So what do we mean by line of sight? The line of sight is the eye contact which you're going to make with the object. Say for example, I'm on the ground and I'm standing here. I'm just standing out here, and from here this is my eye which I'm going to make contact with the tower. Say for example, this is Qutub Minar, which we have taken in the introduction of trigonometry. So this tower top I'm seeing here from here. That means when I'm watching from here, the top of the tower, this is the eye contact I'm making between the top of the tower from here. The person here is making an eye contact with the top of the tower. So that line, the distance from the eye to the top of the tower where the person is watching, is called line of sight. So the line of sight can be in any direction, where if I see straight, this will be the line of sight. If I straight up, the line of sight is here. If I see down, then the line of sight is downwards, is how we understand. But ultimately, the eye contact which I make with the desired object or the object which I would like to look at is the distance between them, which is called the line of sight, the line along the sight. So line of sight derives two basic definitions. One is angle of elevation. Now what is angle of elevation? Let's see what is exactly angle of elevation connected with line of sight. To start with the angle of elevation, I start with the ground. Imagine I stand here. I just stand here, and from there I make an eye contact with the tower which is out here. That means when I watch the top of the tower here, this is the line of sight, and the angle which it makes is called, the triangle is called the angle of elevation. Angle of elevation is the angle made from the ground when I see upwards. If I see downwards, we call that as angle of depression, which we're going to see in the next session. But from the horizontal line, if I just look upwards, then that is called angle of elevation. So this is called the horizontal line along which is taken as the base for watching straight, and from there whatever angle I raise upwards to see the top of the tower or the top of the building, that angle at which I raise upwards is called the angle of elevation. In this case, this being the horizontal line, if this is the eye, through which the horizontal line is this, then I raise to angle theta to see exactly the top of the tower. That angle is called angle of elevation. With the line of sight out here. So this is how we understand the angle of elevation. Next is angle of depression. Angle of depression is generally, as I told you, when I see downwards, and angle of elevation is when I see upwards. Therefore, when I just discuss on angle of depression, let's take a real life problem where I have a ground and I have a building on which I'm just standing. Now this is the building where I stand. So standing here, I want to see an object or a car which is out here. So I'm looking at a car which is on the road from here. That means I'm watching downwards because I'm on the top of the building. When I want to see the car which is down of the building, I watch downwards, which is called angle of depression. But where does angle of depression come here is the biggest question. So to make a note, initially as I told that my horizontal line is the first thing here which is to be made, because my angle is with respect to the horizontal line which makes with my eye contact. So the straight line, the horizontal line through which we take the angle of elevation or the angle of depression. Therefore, for this horizontal line, when I watch here, downwards, then when I'm watching this angle is called angle of depression. So in this case, this angle theta is called angle of depression out here. So because this is downwards, clearly this is angle of depression, and clearly this equals this. Why? Because these two lines are parallel, the ground and the horizontal line are parallel, these two are equal because of alternate angle property. So when this is theta, then immediately this also becomes theta. It's how geometrically we understand the angle being equal in angle of depression. But finally, when I see the object upwards, I get angle of elevation with respect to the horizontal line, and when I see downwards, I get the angle of depression with respect to the same horizontal line. Finally, the angle decided from the horizontal line. So let's see some application-based problems where we use trigonometry in real life. One of the word problems which we're going to discuss as an example topic. To start with, let me have a question where a person is watching the tower 15 meters away. Now, the angle of elevation of the top of the tower as observed by the person is 45 degrees. Now this is the minimum information given through which I have to find ultimately the height of the tower. Find the height of the tower. The question is to find the height of the tower where a person is watching 15 meters away on the top of the tower. So usually such word problems are converted into diagrams and then we solve using the concept of right angled triangles connected with trigonometric ratios. This is how the application of trigonometric ratios comes into existence for the real life problems. Now how do I convert this into a diagram is the biggest question here. So usually when you have such word problems given in the topic of trigonometry, the first thing what we do is we draw the ground, because when there's a person and the tower, a person and a tower cannot exist if there's no base. Therefore, we draw the ground and then the tower on the ground and the person on the ground makes a more meaningful sense. So therefore, for any word problem in trigonometry, we first start with the ground. To start with the ground. Now let's see, here is the person at A, there's a person standing out here. So there is a tower out here exactly 15 meters because it says that a person is watching the tower 15 meters away. That is, if my tower is out here, if this is my tower, if BC is my tower, then the person is exactly standing 15 meters away from the tower. That is AB equals 15 meters. Now, with this information, it is also given that the person is watching the top of the tower making an angle of 45 degrees. That is, when I watch the top of the tower from here, I see that this is the angle of elevation. When I'm watching upwards, it is clearly angle of elevation. Therefore, when I'm watching the top of the tower upwards, the angle is given to be 45. So this is how I get this to be 90. So this obviously tower will be 90 degrees to the ground, and then the person is 15 meters away and the angle is 45. So with this two basic informations, or the third basic information, we try to find the height of the tower, which we assume as h. Because we don't know the height of the tower, I take, let h be the height of the tower, of course in meters, because I convert that in meters. So let h be the height of the tower in meters. So using this right angle triangle ABC, let's see how we can find h. Now, as I see this diagram clearly, I observe that now there are three trigonometric ratios which we have discussed, which are standard: sine theta, cos theta and tan theta. But sine theta is opposite by hypotenuse, but because I don't need AC, I need h, that is the opposite side. Now, because the adjacent side is given and I need to find opposite, we know that the opposite and adjacent sides are related with tan theta. So tan theta helps me in this real life problem, is very important for identification. Therefore, to find the height of the tower, I take tan theta, which is opposite by adjacent. So in triangle ABC, now to start with this triangle, I take tan 45 because I can find the height of the tower if I connect the opposite side with adjacent side. Hypotenuse does not help me in this case. It's of no use taking AC or the hypotenuse for solving the problem. Therefore, connecting opposite and adjacent with tan theta, which is opposite by adjacent, I get this to be, from trigonometric table which we have defined for special angles, tan 45 is clearly 1, and then my BC is h, as can be seen from the triangle ABC, and then my AB is clearly 15 meters, as can be seen in the triangle. Now on cross multiplication, I get h equals 15. That implies the h, which is height of the tower, is 15 meters. So with this, I get that height of the tower is 15 meters is what I get for this problem. Now here we identify that without just measuring the height of the tower with a measuring tape, I can utilize the distance and the angle, which can be easily measured in engineering session, and then I can find the height of the tower using trigonometry. Tan theta is one of the most interesting concepts of trigonometry applied in real life. Let's see the solution for two triangles connected with trigonometry and its applications in real life. Sometimes there are multiple triangles of the same problem through which we identify the different dimensions using the trigonometric ratios, of course. So let's see a problem related with triangles. So initially, to start with, let me take the problem. A person is watching the top of the tower. A person is watching the top of the tower of height 10√3 meters from a distance of 10 10 meters is the question. Now, he moves further and watches the top of the same tower at an angle of 30 degrees. Now I had to find the distance between his two positions is the question out here. So there are many things given out here through which I convert into a diagram and see what exactly I get. Now here, to read carefully, I have a person is watching the top of the tower of height 10 root 3 meters from a distance of 10 meters. He moves further and watches the top of the same tower at an angle of 30 degrees. Now I have to find the distance between his two positions is what we need to find. So therefore, let's convert this into a diagram. The minimum information, I see that I initially draw the ground, which is the most essential factor. Now, there is a person standing. Here is the tower of height 10 root 3 meters. So the height of the tower is 10 root 3 meters. And from here, the person is standing out here and getting to be 10 meters away from the tower. So now we have to take the next information, which says that a person is watching from a distance of 10 meters. Therefore, if the person is initially at A, he is at a distance of 10 meters from the foot of the tower. This is the foot of the tower and this is the top of the tower. So 10 meters away is this. And next, it is also given that he moves further and watches the top of the same tower at an angle of 30 degrees. Now we should know whether the person is moving towards the foot of the tower or away from foot of the tower is the biggest question out here. So this is a very important mathematical property to identify whether the person is moving towards the foot of the tower or away on the right, away from the foot of the tower. So how do we identify this mathematically? So in order to do that, initially, because the person is watching the top of the tower from A, let's try to find this angle. So clearly I identify that this angle is nothing but can be obtained if I use the trigonometric ratio tan theta, because if I use this, CD is the height of the tower. So in triangle ACD, what do I get? In triangle ACD, if I see tan theta, if I take this as theta, then my tan theta is opposite by adjacent, which is opposite side is 10 root 3 and my adjacent is 10, so that this gets cancelled to get root 3. But we know that from trigonometric table or the tabular diagram, tan 60 is root 3. So this comes out to be tan 60 degrees, which is root 3. Therefore, my angle should be 60 degrees is how I extract the angle from the triangular dimensions. So with these two dimensions, I get this theta equals 60 degrees. So using this 60 degrees, I can find out whether the person is moving to the right or left. How do I do that? A very important note that because the person is moving further and watching the top of the tower at an angle of 30 degrees, I see that this angle reduces from 60 to 30. Now when I assume that the angle is reducing, we see that the person is moving away to find the top of the tower. As the person moves closer to the tower, the angle increases, and as the person is moving away from the tower, the angle decreases. Therefore, 60 to 30 degrees clearly implies the angle is decreasing, thus making us understand that the person is moving towards the right, that is away from the foot of the tower. So that if he moves until here at the point B, then from here this is the angle which is 30, is how we clearly understand. If the angle was given as 100 degrees, then we clearly identify that the person is moving towards, so that this becomes 100 degrees. So the angles are identified through the increase or decrease, and then the direction decided by the angle. In this case, 30 degrees implies towards the right. Now the question here is, find the distance between his two positions. So if I take this as x, then I have this x which I need to find in the given problem. How do I find x? Now this is related to solution for two triangles, because this problem connected with trigonometric ratios has two triangles. One is right angle triangle ACD, and next is the right angle triangle BCD, which give us the outcome of solving from each of the triangles. So let's see how we can solve from each of the right angle triangles as identified in this problem. So I take the distance between the two positions of the person as x, where let x be the distance between the two positions of the person, is what we take. So using this distance x in meters, let's see how x can be found from the given right angle triangles. So initially I take the right angle triangle BDC. In triangle BDC, I find that for this right angle triangle, if I take tan 30 degrees, then that 30 degrees is clearly opposite by adjacent, that is DC by BC. Opposite side by adjacent side is what we get. But what is tan 30? We know that tan 30 is 1 over root 3. So therefore 1 over root 3 is DC, which is 10 root 3. And then my BC, which is 10 plus x, because this on the whole is 10 plus x, gives me the whole of BC. So this is 10 plus x, which I get. Now when I cross multiply this equation, I get this as 10 plus x is 10 root 3 times root 3 is what I get for the given equation when cross multiplied. Now simplifying further, I get this to be 10 plus x is 10 times of root 3 plus root 3 is 10 times of 3. So that this is x is 30 minus 10, which is 20. Therefore x is 20 meters. Therefore this 20 meters makes me understand that implies the distance between two of his positions is 20 meters, is how I understand the real life problem connected with trigonometry and its ratios.